I'm your host, John Myers, live from Stillwater, Oklahoma. We have got a great show tonight. It's John Myers. Hey, everybody. Gotta have my notes. It's John Myers from the Kicker UnMasked studios. Gotta have my notes. Alternator. Hey, everybody. We have fun. Hey, everybody. Hit like and subscribe. Right here, right now. It's John Myers. We like to give stuff away. Alternator. Post some more pictures. We got to thank Steve and Becky live from Stillwater, Oklahoma. Don't forget Texas Roadhouse right here, right now. Hey, everybody. Don't forget right here, right now. We have got a great show tonight. Hey, everybody. Had a great dinner tonight. It's John Myers. Right here, right now. Had a great dinner tonight. So, hey, everybody. So, housekeeping. Had a great dinner tonight. So, alternator. Housekeeping. Housekeeping. So, Tuesday night. Housekeeping. From the Kicker UnMasked studios. Housekeeping. Right here, right now. Hey, everybody. So, it's John Myers. Hey, everybody. It's John Myers from the Kicker UnMasked studios. Hey, everybody. From the Kicker UnMasked studios. It's John Myers. Right here, right now. We have got a great show tonight. Hey, everybody. We have got a great show tonight. It's John Myers. Hey, everybody.
Right here.
Hey, everybody. It is Tuesday night, 7:30 Central Time, right here in Stillwater, Oklahoma. You're joining us from the Stillwater Designs, otherwise known as Kicker Car Audio Studios, right here in wonderful Stillwater, Oklahoma. Guys, we had a great show the last time. We had Aaron and Jacob talking about the SEMA show, and it was good to go back to that show. That is absolutely my favorite show of the year. And it was good to be back, and there was a lot of really cool stuff. There's no way that any video or pictures will ever do it justice. But we got a great crew on tap tonight. We've got Bill Frog hiding back there. We've got Ernie manning his usual chair, and JW is kind of down in the weather. So Sandy jumped right in to fill in for him. JW, hope you get feeling better. And as long as we're on that subject, Andy, unfortunately, is under the weather as well. So we would not be seeing an after show from Andy tonight. So hope he gets better, and hope everything's well with JW. So we got a great show coming up tonight. We're going to talk about the Gold Series, the Warhorse, and the usual array of cool, fun pictures and stuff. And, we're actually going to power up this Warhorse and show you a few gadgets that it's got coming with it. So, guys, stay tuned for a great show. We're going to be coming back up with Joe Hobart in just about a minute. So, see ya soon.
It's been a long road since the original Kicker christened that first pickup truck. It kicked off a car audio renaissance, and upgrading your music in a vehicle was a requirement. America's music machines became living loud over your passion, your emotion, your existence. Outdoors or on the open road, your sound is Kicker.
Hey guys, thanks for coming back. I know you're getting ready for an exciting show, and I've been looking forward to this show since we decided to do it for quite a while, so it should be a lot of fun. But as always, we got some stuff we want to get out of the way. If you guys like what you see, make sure you hit the like and subscribe button so we can get all those wonderful viewers tabulated so we know how good we're doing. And if you don't like it, let us know. Make sure if you got comments, questions, or anything else, send us suggestions for shows or, people you want to see on the show. Things you like, things you don't like. If we don't hear from you, we don't know for sure. So, we're here to do whatever you guys want. We're going to have some fun at it no matter what we do. And talking about having fun means we're going to give away stuff. I'm sure that's a big surprise, those of you guys that have been here for like the beginning of this. But for those of you that are new, we actually give away stuff on every single show. So tonight is no exception. If Ernie will pull up my laptop, to register for tonight's giveaway prizes, if you don't already have this on speed dial or bookmark in your browser, it's going to be kicker.com/UMweekly for Unmasked Weekly. And you're going to see this page. It's going to tell you what we're giving away tonight. You go down to the bottom, and you can ignore what my computer says because I would assume this promotion is live. I'm not sure why it sends in 115 minutes, but hopefully you guys can register. And, I don't think we want to stay up here for almost 2 hours before we give stuff away. But, hey, if we have to, we have to. We'll do it. So, as usual, tonight we're going to give away third place is going to get the EB400, the wireless Bluetooth earbuds, the gray kicker t-shirt, and a kicker koozie. The second prize, or the runner-up prize to the grand prize, is going to be a set of the Tabor 2. Those are wireless headphones. They're also Bluetooth, and they actually come with a cable. So if you forget to charge them, you can still use them. It's actually kind of cool. And these things sound great. They got soft over-the-ear cups, and they do absolutely make all your music sound better. And the grand prize winner is going to win the Cush NCs, which are the noise-canceling headphones, which are my favorite. I keep talking about every time I'm up here that unfortunately with the way the supply chains are working, we can't get enough chips to make these things. So when our current inventory is gone, they are gone. So if you really want them and you're not sure if you're going to win them on the show, you might want to get online and order those. You can order those at kicker.com. You can order anything we sell on kicker.com. And like I say, check it out. It's a lot of fun. There's a lot of cool stuff on kicker.com. So, Kicker Club. Even though Andy's not on tonight, make sure you guys register for Kicker Club. It is the biggest on-site gathering for Kicker fans where you can ask questions and get, answers posted from all kinds of people and some experts. I mean, I've seen Joe in there. I've been in there, Ernie, Bill, Jacob, Aaron, Carlos. So you never know who's going to be in there answering your questions. So if you have questions that, you don't get answered that way, feel free to send us an email and to get, to our text. And we got, 4 great texts up there. Basically, it's support@kicker.com. So send an email, and we're going to actually feature a couple questions from that actual site here in just a little bit near the end of the show, right before we give away some cool stuff. So that is what we got going on for giveaways. But, I think we're going to dial it in a little bit closer here. Ernie, we need to talk about the Gold Series. Let's just jump right into this, guys. So it is our 50th anniversary, right? Ernie, I think we got a cool logo for our 50th anniversary coming up in 2023. So everybody said, hey, you need something cool. What can you, do for a 50th anniversary? So yes, we brought back the Gold Series. So Ernie, if you go a little close shot on the woofers right here in front of me, we're going to do a little bit of comparison and kind of show you, from the old school to the new school, what we got going on. If you notice, just by the look of these two woofers, they are quite a bit different just on the face. What I think is really interesting, and I'm not sure when this has happened, but the new Gold Series, the 50th anniversary, is literally half of an inch bigger in diameter than the old one. It's still a 10-inch. I'm not sure where it gained that extra half of an inch, but where most of the stuff in this world now is getting smaller and smaller, apparently the speakers are getting bigger. So that is really cool. But if you look at the face of the speakers, I mean, it's got pretty much the same design cone. They actually have the little dimples in the cone, both the new one and the old one. They've got that great Kicker logo in the center. Something you will notice quite a difference if you look at the surround. There is a huge difference in the surrounds in the two speakers. The old series got a little bit smaller surround. It is a treated foam surround. We've actually had some people comment that, they wish we would have kept a little more traditional surround, but, we want to bring this thing up into the 21st century. We want to make sure it's better than it was before, and we basically taken this speaker and put about 36, 37 years worth of technology into it to make it absolutely an incredible woofer. So it's got a Santoprene rib surround, it's got a much taller surround and a much wider surround, so it's got a lot more travel and a lot more power handling. So I know you guys have commented about how much you like the sound of the original solo, or the Gold Series, which came out in 1986, but I think the 50th anniversary, when you guys get listening to these things, they are going to be incredible. But we're going to show you some more differences. I'm going to go ahead and take these sandbags out of the way. It's the only way I can keep them from going anywhere, and hopefully these things don't explode. So if you notice right away, there's a big difference in mounting depth. The new Kicker Gold Series has a much larger magnet. It's got a deeper structure. Therefore, it definitely has a lot more excursion, a lot more output. Now, if you look on the surface, the gaskets, this is actually a cork and paper gasket. This is actually a plastic gasket with a kind of a rubber insert on the front that looks very much like the old cork gasket and the paper one to kind of keep that old traditional look. Now, when we first started doing the Gold Series, they had single stitch surround, where the new ones are going to be a double stitch surround. So big difference in the looks of the speakers and the performance, and that difference continues to build up as we go to the back side. And let's go ahead and turn them around the right way, because they are heavy. So if we look at the back of the speaker, you got that great, tribute to the old Kicker logo on the back plate, which, is really kind of cool. In fact, a lot of changes just on that back plate. The sticker is very similar, but if you notice the new Gold Series, the 50th anniversary has got the holes in the back plate for the forced air cooling. That's going to keep this speaker about 20% cool than its predecessor for the same power input. And the old speaker had a bumped magnet on the back, or bumped back plate. You see the little bump back here, and that's to give it more travel. That's one of the reasons why we came out with the Gold Series initially, is because Steve wanted to come out with a speaker that had more output. And we talk about bore and stroke. Well, that gives you a longer stroke, gives you more cone travel before it bottoms out. So what we've done with the new speaker, we don't have that bump back plate. We've just extended that whole pole piece in the rear of that speaker, and it does have a much larger, more powerful magnet structure. Also, as we look at the back of the speakers, a little bit of difference. This has your typical, spade terminals, 2 positive, 2 negative. If we look at the new subwoofer, we actually have dual voice coils. So these are dual voice coil. They are all 4 ohm coils. So you have all 3 sizes, the 10, 12, and the 15, which is what they're going to be available in, have dual 4 ohm voice coils, and that's by these gold-plated terminals. So great looking speakers. I've heard them. They sound fantastic. You guys are going to love these speakers. Where they fit in the lineup is, believe it or not, right above the Comp R and right below the Comp Q. So these are going to be a hot sounding speaker, and they are going to be very, very popular. So we're going to do a little shifting up front here. We got a few things we're going to change around. So we're going to go to a quick little break while we rearrange the table. And I'm going to bring up Joe Hobart, our special guest for the night. And we're going to talk Warhorse, because I know that's what you guys have been waiting for. I know I have. I've got a bunch of questions I want to ask myself. So stay tuned. Right after this, we'll have Joe Hobart and the Warhorse Amplifier.
And it's in my DNA. My pals at Kicker Marine Audio gave me a chance to take the music, what I love and listen to, at home, on stage, and in the car, onto the water. Hi, this is Jason Bonham, and I want to say a big thank you to my friends at Kicker Audio for inspiring the songs and the stories behind the music that inspires America. Go overboard! This is your time.
Welcome back, guys. I knew you'd probably not stray away after that, because I know you guys are just as excited to see what we're going to see up here and get a little breakdown with Joe. But first of all, we need some background. Who are you and what do you do?
Well, as most of you probably know, I'm Joe Hobart. I'm the Director of Electrical Engineering here at Stillwater Designs. I came to this company 16 years ago now.
I'd say it's been at least 15 that I remember.
2006. With the acquisition of Soundgate back in the day. So I originally did vehicle interfaces and data bus stuff. Been here ever since.
I'm glad you're doing it, because I sure don't understand any of that stuff. So Absolutely. We got a cool little project up here. We talk about the old Warhorse amplifier. When we came out with that amp, I think it was 2004, 2005. I don't even remember.
It was actually 9 months after I got here.
Okay, so whatever, you do the math.
2007-ish.
Yeah, my brain's not working that quick, but 10,000 watt mono amplifier. It was a push-pull, and what's really kind of ironic is I actually drove down to do the video, the actual setup video, because it's so unconventional the way it worked. It was actually push-pull. You had to have a dual voice coil speaker, at that time to get the power output, and that thing, 10,000 watts, almost 900 amps of current draw. But we drove down to Shreveport to do the video, and it was really, kind of odd. We had Mike Van Horn doing all the video for us, but I did the video on how to hook it up, and guess what? In the Warhorse van, the first demo vehicle, I hooked it up wrong. Hey, I admit it. I'm human. Things happen. I just, spaced it off. I just wired everything up like it was, a single output channel on the amplifier. And my gosh, it just didn't sound right. You had some woofers moving out, and the other two woofers were moving in. It didn't work out the way it was supposed to. But hey, we got that corrected. And like I say, I'm not afraid to admit it. I make mistakes. I mean, in car audio, I can't tell you how many mistakes.
Oh, if you haven't made a mistake in car audio, you haven't done car audio.
Yeah, you're not doing anything.
I remember I was sitting in training when the Warhorse amp was coming out, and they were doing a training to training. It's like I was training on soundgate parts. And I was like reading away, doing something I hear. Well, you hook up one woofer to one side, and you hook up the other side of the voice coil to the other, and one pushes and one pulls. And I'm like, whoa, wait, hold on here.
That doesn't sound right.
Well, I had done something similar with a Dyer Audio on an enclosed sub box for home, where you could basically take this big potentiometer and crank it one way to make it sound small and sealed, crank it the other way to make it sound big and boomy for a movie.
I like it.
But it was an enclosed system, right? And so I hadn't heard of anybody doing it at the amplifier level before, so that was interesting.
And I can't remember why we did that. I mean, is that just to get the power at that time?
It saved
the
efficiency. So we were trying to get to something that was 90% efficient, which of course is not easy at high power levels.
Do you remember what it was for efficiency?
It was like 90.1, 90.2. I mean, it barely broke 90. The problem is if you'd have brought the two phases back in, you'd have been at like 86, 84. So, you're trying to get all the power you could.
I know we wasted a little bit of money on that amplifier and cooling fans because I don't think we ever got them to turn on, did we?
No, they were computer controlled, but you really never needed them. So, I mean, that kind of follows suit in the new line too.
So, now, you talk about power supply classes. You had the Class A, you got the Class A, B, and the Class D. What was the original Warhorse? Do we have a classification? How was it different than a conventional amplifier without getting, really into the weeds?
It was a Class D amplifier, but non-rectified. So it means it wasn't brought back together, right? But the power supplies, what made that thing kind of unique, they were big toroidal power supplies, whereas instead of having FETs make the power, the toroids were driven on the input, and the power came outside of that. So it's kind of like you reversed the way a power supply normally works in that case. It was an interesting concept. Common, the guy that worked on that, spent years on that project trying to get that to work right. And the toroid power supplies actually work really effectively. They're very efficient, but they're also really, really, really expensive.
Yeah, so, those planar transformers too were kind of a hybrid.
Yeah, the planar transformers, all that stuff was very pricey in that amplifier, but it came out to be very unique and gorgeous amplifier.
We did it first.
Yeah.
And if we say it's going to do it, in fact, if I remember, I think that amplifier was capable of 12,866 watts. If you
something like that,
you add it up right at like 897 amps of current.
A
whole lot of current.
We all have that in our vehicle.
Yeah, exactly. Just laying around. So, which brings us, back to the whole SPL thing's gotten really crazy, and we kind of stepped away from it for a while, and the big push with the new L7X coming out, we got to have something to power it. So we have for you guys right in front of us. We just introduced it at the SEMA show a couple weeks ago, 3 weeks ago. The new Warhorse amplifier. It's the 3600.1, which means roughly 3,600 watts into one channel, right?
At least. Yeah.
At least. Now, we're not going to tell you exactly what it does. If you guys keep tuning, at some point, probably not this year, but, at some point next year, maybe first quarter of next year, we'll get one of those out. We'll put it on the dyno and show you what it really does, because you guys are going to be surprised. We were. So, cool. So, let's dig into this thing a little bit if you want, Joe.
So let's start with features. Let's go from the outside in here, right? Make this easy.
What do we got up here? This first.
So currently we have, of course, we have the new Warhorse amp in the chassis, like you would have seen in the Bronco if you're at SEMA. We have it out, another version outside the chassis, so we can look at it piece by piece and kind of go through how it works. And then we have a competitive full bridge amplifier here that is typical of what you see in the marketplace today, that's rated at 5,000 watts. And so we're kind of going to go through and talk about the differences and why and the reasons for why we design things like we do.
And there's, a good reason why we do this, because if you just look at the box of an amplifier, all things being equal, price wins, right?
Yep.
I mean, if they're exactly the same,
yep.
it's got to be the cheapest one. Well, unfortunately, there's a lot of things that go on inside the products, a lot of technology that, a lot of engineering that we put into our products that you will never see, you'll probably never even know is there. And I always say, people want all the technology in the world, they just don't want to know anything about it. They just want it to be there and work when they want it. So why don't you hold those up so you guys can see the differences in these two circuit boards. So I'm holding the competitive 5,000 watt amplifier. And you're holding, obviously, the circuit board for the
3600 one.
Yeah. So, I'm not saying that this amp may not do 5,000 watts, but, when you start talking about the construction, why the differences in the two, Joe? Why? It looks like there's more capacitors, there's more coils, there's more output devices, but yet ours is rated less power than what this one is.
Yeah, and most of that comes down to performance and reliability, right? Could we make a cheaper amplifier? Yes. Would it be less reliable? Yes. And so for us, we have certain standards that we have to maintain in this company and a certain return rate that we shoot for in life. I say shoot for because it doesn't always work that way out of the gate, but we try to. And we sell a lot of amplifiers. We're not a small company. And so if you get a high return rate, your returns can become overwhelming very quickly. So for us, there's a ton of testing and development that goes on the front side to make sure that everything performs how we want it for years to come down the road without any glitches or problems, right? We don't want it to make it 2 months outside of warranty and fail. We don't want
That's not a good customer experience.
No, we don't want it the first time that you accidentally put the wrong load on it, it dies, right? So we build all these protections into these things to make sure that they're as reliable as they can possibly be having silicone in them, because anything that has silicone in it is sooner or later going to have a failure. The goal is to make it be as far out there as possible and last as long as possible.
Well, another quick question. You touched on a subject that I think will make a big difference in, what people understand about amplifiers. You talked full bridge. Well, tell us the difference between full bridge and half bridge.
So we've talked about this on a previous show, but I'm sure not everybody was listening in here.
I know I wasn't. I wouldn't ask the question.
In the aftermarket world, especially the SPL world, right now there's this thought process out there that full bridges are kind of cheap and unreliable, and half bridges, Korean amps, as a lot of people call them, are more reliable. Well, the reality is I would say the big three, us, Alpine, JL, Fosgate, the big four, whatever you want to call it, have been making full bridge and half bridge amps for 20 years now, Class D amplifiers. And both of them are reliable. It all depends on how they're built, right? How they're designed. It's more about that than it is the topology. Because really all a full bridge amp is two half bridge amps put together. So if you're saying a half bridge amp is more reliable, so if you grab two of them and strap them, they're now technically a full bridge amp, so shouldn't they be less reliable? But they're not, right? It's not about that, it's about the design.
That almost sounds logical.
Yeah, it is. This is all physics, guys. So, half bridge amplifier, how they work is one side references ground. Might not be the ground lead on the speaker out, it might be the positive, but one of the sides will reference ground. The other side will be driven, and that's what drives your sine wave. So if you look at them with a scope, you'll see one side is ground and one side has a sine wave on it. On a full bridge amplifier, you'll see that both channels don't reference ground, and both of them have a sine wave on it in opposite directions. And why in opposite directions? Well, that way you get double the output, right? One goes up, one goes down, the speaker moves twice as far, twice the swing. Besides that, then you get into power supplies or output stage differences, right? But a half bridge or full bridge can be a Class A amp, can be a Class AB amp, can be a Class D amp. It doesn't matter the topology, it's the output stage. Then in these amplifiers, right, both of these are Class D. Both of these are full bridge. So if you're going, well, this one's 5,000 watts, right? And this one's
that's what they claim.
Yeah, and this one's 3,600. So why the difference? And so this we can get into. So ours is what we call a symmetrical design. If you actually look at this, you'll see 4 inputs right down the middle of the PCB.
I'd ask Ernie to pull up the picture, but he's messing with the camera back here. So we'll pull up a close-up of the
circuit
circuit board.
There's 4 inputs right down the middle of the PCB. I mean middle of the PCB, exactly. And the reason for this is the power's on the inside and the grounds are on the outside. And what that allows us to do on the bottom side of this PCB, if you look at this, you'll see the ground traces are symmetrical to the power supply, and the power traces are symmetrical to the power supply. That allows us to make sure that each rail, when it pushes and it pulls, you get a thing called spiking, right? So you push a bunch of energy down this. When you let it go, what happens? You get a spike. Well, if the spiking gets too big, then you start blowing up devices, because devices have a voltage they're rated at, and then an avalanche. And if they go over voltage and you get into avalanche, you'll shorten the life of the FET. Now, a lot of cheap ramps will...
Actually, just a quick analogy of that, something that just popped in my mind, which is really weird, why I like this kind of stuff. Something like what they call a water hammer, if you've ever heard that term. If you have a lot of water, you've got a lot of energy going through the water pipe, and you slam that valve shut, well, all that water is still trying to come, so it basically is like a liquid hammer, and that's how you end up exploding your pipes. Well, this doesn't explode the pipes, it just explodes the output devices.
Yep, basically.
Or the caps. Or
the caps, or the rectifier diodes, or whatever happens to be in the path.
Whatever happens to go, it's not good for your amplifier, so that's why you spend a lot of time to make sure we don't have these issues, and we put decent rated value of components in the amps.
And so you got the symmetrical power supply design, right? So everything comes in, everything goes out. You come to the other side, and on this side you're looking at 4 individual power supplies, all set up in push-pull, wired together to make a very efficient power supply stage. If I remember right, this power supply stage is almost like 92% efficient. So up to this part of the amplifier, we're doing a very good job of getting power up and into this amp to try to get it out without wasting anything in heat, right? You'll also notice then we have USCON caps. There's 4 4700 micros, so there's let's see, I did the math earlier. There's 18
Jeff Smith's in the house. Hey,
18,800 microfarads worth of caps on the power supply to try to keep the power supply stable during bass notes. After that, we come out and go into the output stages. Of course, you've got a positive and negative output stage. They're actually both running 4 FETs, so there's 8 FETs on this output stage currently. You notice there's 4 on the bottom, and then 2 up on each side. So we currently have, at this point, 16 power supply FETs to dissipate the energy that we need and make sure it's stable, 4 power supply cores, pair of caps for each side, and then you have your 8 outputs. I will tell you right now, this is not the current version of this amplifier. The current version has 12 output FETs, because we found that they were getting too hot for our liking when we ran them really hard on the APs.
That's why we test them.
And so we've decided to split that load out even more. So at this point,
a lot of people
have 30 FETs in this amplifier.
I don't think a lot of people understand. When you first design something, it works really good on paper, and then you put it in the field. It's like, we need to make some changes, just like that L7X. Or what do we want, Rev 24 in that woofer? I'm not sure how many we are in this amplifier, but I know it's definitely more than 4.
Yeah, this is definitely more than 4 at this point. And some of the problems you run into when you go into higher power, and it's things that you see in some of these other amplifiers that are in the lower price range, more cost-effective stuff. The higher power that you're switching, the more noise you make. So what does that do to the amplifier? 1, your THD gets worse. 2, your signal to noise gets worse, right? THD goes up, signal to noise goes down. It's hard to combat, because when you're switching this much current, it makes a ton of noise. There's just a lot of on and off switching noise. And so the board layout becomes very, very important. That's one of the main reasons for our symmetrical, is to transfer energy and keep the noise down.
And we do all the board designs in-house.
Yeah, all these are done in-house in Stillwater. Pretty much every amplifier you can buy from us at this point has been designed here now.
Yeah, which is really cool. In fact, if I remember, don't you wind some of our own toroid coils?
Well, these were all wound in-house for prototyping. Yeah, we do all of it. Start to finish, order the PCBs, we assemble the PCBs here, we build them up, test them, and move on to the next round until we get to the point where we're ready to send them off for a production build to see, to work out the bugs in production.
Now, we started talking about the power supply. Tell the differences between that power supply and this one, because obviously I'm seeing some E-type coils here, transformers.
Well, yeah, that's for noise. These are actually, so this is this version, right, the 5,000 watt amp. This one has 2 transformers. They're E-coils, as he pointed out. They're wrapped to try to reduce noise because these ring a lot because they're pulling a ton of current through.
The coils actually vibrate.
Right? Yeah, the coils actually ring.
Squeal.
And The U.S. doesn't have this law currently. If you're not running Bluetooth or Wi-Fi, you don't have to pass any radiated emission noises when you're making a car audio amplifier for the U.S. But pretty much everywhere else does, whether it's the EU, whether it's Australia, New Zealand, doesn't matter. They all have very strict RF radiated noise.
That's not a bad idea.
And so all of our amplifiers pretty much go through almost all of that testing at this point, because we're a multinational company, so we have to be there, able to pass everywhere.
Well, the last thing you want is put an amplifier in a vehicle and have it disable your analog brakes or one of the warning systems.
Nowadays
now you get sued.
all kinds of things could go wrong, right?
So,
but the other advantage to that is we don't mess with your FM, AM, your satellite, right? Because of that, because we have to keep our emissions low. And there's two types of emissions. There's radiated in the air, and then there's also conducted out the power wires and ground. And both of those can cause problems. You'll actually notice over on this amplifier, there's one little, might be this one, there's one little toroid and cap on the edge, and that's actually to stop noise going back out the amplifier, power and ground. But we do that on pretty much all of our amplifiers at this point. So we stop radiated noise, we stop conducted noise, get them down below the levels when we test. As you know, we're currently building new labs so we can do more of this in-house.
yeah, and that's going to be cool. We'll have another show for you guys when we're talking about the new testing labs we're doing in-house to really control this process. I mean, we're never going to be the cheapest product out there, guys, but I think we're going to obviously be one of the most reliable and, the features that really make a difference in the long run, not just that initial, what is that one power number, that's not, all you need to worry about.
All right, and so then you're talking about this, right? So they're trying to stop these from ringing, lower the noise. Comes out, goes into their power supply. Let's see my notes here because I did this earlier. This one has 12 power supply FETs. I don't know what voltage they are because they wipe theirs. Ours are, I think at this point, 150 volt FETs.
When you say they wipe them, they just remove the label.
They remove the label on them, yeah.
So you can't tell.
So I'm not sure what they are.
So what are they hiding? Intent, nudge, nudge.
And they're doing another thing to try to stop the noise here, right? So because of this, they're doing high voltage out to their FETs, lots of current through fewer FETs. You get a bunch of switching noise. So these are 60 volt caps. They've actually got 2200 cap micro on each side of the power supply. I know there's a third one here, but wait. So they have very, very little capacitance on each side. If you noticed on ours, right, we have almost 9,000 on each side. They're putting 2200 on each side to filter. Then after the rectifier diodes, they put this last cap on there to try to filter it after it's been rectified already. So they're doing 2 stages of filtering to try to bring the noise down. And then of course you go into their Class D stage, which has 8 output FETs. Versus what we have. And out you go. So what are the disadvantages to this? Well, one, these get hot, right? That's the biggest problem.
Yeah, when you run more current through the devices, they get a lot warmer.
They get hot,
right?
right?
We keep adding devices to keep that temperature down.
And the hotter they get, the more the RDS on gets, which is the resistance to on, which is a very important
Thermal runaway?
It's a very important feature on FETs, right? Your RDS on really determines how much energy it takes to turn the FET on fully. And as they get hotter, that raises, right? And so the goal is to keep the FETs as cool as possible and get the heat out of them. And in a lot of cases, that's why we use more FETs to dissipate the heat so you can run longer. One of the things that we do currently, is we don't put our amplifier label on our amplifiers this way, but we are basically testing to what's called CTA 2006C testing, which for the big guys, Alpine, JL, Fosgate, us, those are the numbers that everybody kind of has come together and agreed to test to. One of those tests is 60 seconds full power. Once you're done with 60 seconds, that's what you can rate your amplifier at, both bandwidth and power, right? And so our amplifiers have to play 60 seconds full power period to a fixed load.
And you'd think that's kind of weird. People think, 60 seconds, that's all it's got to play, but there's a lot of them that don't do that.
Well, so the problem is it's like this style of amplifier, and this is kind of one of the reasons these have gotten kind of a bad rap in the industry, is these are really, the way they're designed is they're counting on box rise, and they're counting on music not to be steady state, i.e. not a sine wave, not a long 20-second bass note in a rap song, right? They're counting on small bursts of energy across the frequency spectrum, so you're not really playing 1 ohm or half ohm or whatever your rated is, right? So it's a lot less current than when you're playing into a fixed load. And that is why these will work with an amp dyno when they do the test most of the time, because the amp dyno has like a little 8-second burst that climbs over the 8 seconds to get to peak power. So it's so short that the heat doesn't build up in the FETs and they're able to survive that test. I think they really kind of designed these around trying to pass amp dynos, right? Because that's what most is
That's
out
what
there.
everybody's using.
That's what everybody knows
yeah.
of in the commercial, consumer realm, right? That's what they can afford to buy.
Basically, it's like insider trading.
Well, this is what we would call dynamic power, right?
Right.
So this will make dynamic power. The problem is with trying to make RMS power out of this and trying to actually run a power sweep is they normally fail during the power sweep. We've bought a bunch of different brands and a bunch of different types of these, and unfortunately all of them have pretty much never made it through a power sweep. And so we knew when we started to play into this high power realm, we can't do this. This is not something that will work for us as a company, right? But we do know that there are some things here that they've done a decent job at, right? They've made high power rails. They make them fairly efficient. Their THD isn't very good. The SNR is not very good.
And they don't care on it.
But they don't really care, right? So for us, though, SNR, THD, we believe the ability of the amplifier to accurately really produce whatever's being put into it.
Music.
Is important. Music, yeah, hopefully in most cases.
That's what they call it normally.
And so this was very important for us, right? So not only is this amp musical, like you put it on anything you want to, it's very efficient. Most, like you'll see the amp dyno tests and they'll have the clamp meter on the amp dyno and they'll say, they'll do the math and they say like 80% efficient, right? Unfortunately, meters average. And the amp dyno test is so fast at that last little peak of energy draw that you're not really seeing what the real efficiency is. So if you start looking at like user manuals and specs, you'll see 70%, 80% efficient, whatever the number is. What people don't realize is that's at 4 ohms generally. Every time you drop an impedance, your efficiency goes down because you're pulling more current. So like in this amplifier, at 1 ohm, what it's rated at, it's 82.79% efficient over a 20 sample piece. And that's the other thing that changes, right? There's so many different parts in these, you're gonna have some variances, just like you'll see burst sheet variances. Everything
stack
varies.
tolerances.
Yeah. And so what we try to do is once we do all this, right, we come out with a number that's below it. So even these are 82, we'll probably say 80 on the packaging, right? And that's kind of our standard thing is we always round down to the next, to make sure everything will be better than what we actually say it is if you actually measured it.
Notice big difference. I mean, single set of 1-aught inputs, dual set of 1-aught inputs. Looks like we got 8-gauge speaker terminals versus a pair of 4-gauge output terminals.
Yeah, you'll see this as a pair of 4-gauge outs. So if you want to wire to 1 to each voice coil of a Solo X, right? That's nice,
probably what's going to happen.
Nice big direct. I mean, I know we say 2,000 watts, but I personally would run.
Rated.
I would personally run one of these to each sub after listening to them and playing with them.
How about 1 per coil?
Yeah, well, yeah, I could do that too.
For specific applications.
If you're doing it in the circle application, yeah. So a couple other things with this amplifier, right? True efficiency is almost 83%. We are running on 60 volt rails. As you'll see, as you probably saw here, we had 80 volt caps, right, on this amplifier. And you say, well, 80 volt caps, why only 60 volt rails? And that comes back to what we were talking about before, spiking, right? So when you start pulling a bunch of current, no matter how good a board layout you do, instead of having a nice square wave, you get this square wave with a nice peak here. And if that peak gets too high, you'll bubble the caps up and sooner or later and blow them up, right? This one over here.
Let the magic smoke out.
Right, these guys are running at a high voltage. They got 160 volt caps. I'm sure they're probably running 100 volt rails because the spiking on all the other amps we've looked at is very high on this type of design. So they have to be a long ways away from their cap voltage to make sure they don't pop the caps. And so you end up in those type of things, right? So on this amplifier, you can see they've got 160 volt caps. If you can, I don't know if you can read them in any of the places.
Probably not.
Probably not. So 160 volt caps on there. So they're running really high voltage rail and making that make up for the current that they're not able to make, right?
Just wattage is voltage times current.
Wattage is voltage times current. And so that's what they're trying to do in these. The problem with that is the higher the voltage rail, the more noise you have. You're stuck in this cycle of how bad, how good can I make a bad
design,
topology design, right? But this is cheap, and there's no question about it, right? These are very cost effective, low part count. There's nothing to be said with that. And so there's always going to be a customer and a place for this. And in the right application, they work well. It's just not who we are.
Yeah, it's not the game that we're trying to play.
And so, we have our standards and they have theirs. So as you go through this, right, we talked about the symmetrical. You're symmetrical on the bottom, symmetrical layout here, and then after that you get into all small signal stuff, and that's impossible to be symmetrical. But the power comes out the top side and goes into the outputs, right? About the only place you'll see that there's not a symmetrical run of high power here. And then on the top side, of course, once again, symmetrical again, power supplies, and everything heads out. Has our fit inputs and has some special features for the competition world that we can talk about here in a minute.
Yeah, we go into all that fun stuff. Now, the other thing that I noticed is on this amplifier, they have one fan.
Yeah, and their fan's kind of interesting. So
I've never seen one mounted like that.
It sandwiches between the housing, and they've got a little gap, right? So they got like a little 5mm gap down here so they don't short. And it basically pushes amp down that gap to actually cool the housing, not the FETs. But the FETs and the PCB are all bolted directly to the housing, and the PCB is bolted every like inch here. And so I think that basically they're just trying to cool the housing enough and hoping that the housing will
cool the FETs.
Cool the FETs.
Now, we were talking earlier about, the type of, conductive grease and, the pads, and all that costs money.
Yeah, so in these amplifiers, right, they're trying to make something as cost effective as possible. So typically these FETs will be mounted directly to the heat sink with just some thermal grease on it. There's some drawbacks to that. It's hard to get a good compression in a lot of cases. It's hard to get all the heat out of them. We've actually taken some of these amps and modified them with different type of ceramic pads, and they've actually gotten better performance when we do that as far as heat transfer. But all that stuff costs money. Silicone pads are not cheap for an amplifier like this. I think they add up being like $3, $4 for the silicone pads. When you add it up.
That doesn't sound like a lot, but you'd figure, in the grand scheme of things, $3 extra in one part is going to be a big difference in the bottom end.
Yeah, it adds up all. You got 25, 40, 30 FETs. Each one of these caps is like $2 or $3. These are $5, right? So all this stuff adds up real quick as you're starting to put more and more of them on the board. But for us, it's all about the performance and reliability, and that's why we've gone this direction. Now you'll notice, it is bigger than a traditional full bridge, but it's still smaller than any half bridge design of similar power that you'll find in most cases, right? And that is the biggest advantage of full bridge, right? You can make more power in a smaller space more efficiently. So it's a great way to do that. But there's trade-offs like with everything, right? So you got to have good power supplies on both sides because you're not driving just one side.
Yeah. And they got to be equal. They got to be matched.
You've got two of these instead of just one on a half bridge, right? So the reality is like the output stage of a half bridge amplifier is actually cheaper than the output stage of a full bridge because you only have half the components. On the flip side, though, the power supply on a full bridge amplifier normally can be lower voltage because you're driving both sides, so you can have two to get the rail instead of just one. And so there's this, how do you, volleyball, how do you go out, pick and choose how you want to do it, whether you're just going to do a blue steer, whether you're going to do a split rail or whatever you're going to do. There's different topologies, but it's how you put the whole mixture together when you're making the pizza. Yeah, ends up getting what you,
and how does it
taste
want. In the end?
Yeah.
And did you burn it?
These have definitely been burnt in. But, so that's kind of the inside guts that we've talked about, right? Very ruggedly built, extra components, overbuilt really. Probably underrated. We could probably rate it higher and still have plenty of headroom, but this is what we're trying to bring to the market in the last 4 or 5 years, right? The stuff that we've been putting out, like if you get a CXA 601, I think a lot of those have been amp dynoed, 980,000 watts, depending on which one you grab, right? There's a lot of headroom on these amplifiers, and that's the goal, right? Is to make sure that they always overperform for what we say they do, no matter what line it is.
Keeps the reliability up there.
Yep. So with all that, this amplifier has a bunch of new features. That aren't
some pretty cool features.
That aren't traditional, yeah. Just from the body of the amplifier, right? These are cast-in caps.
I know you're not back there, Ernie, but if whoever's back there, if you can pull up my laptop quick. On the top row. I'm not sure if that's Bill or Sandy back there, man on the board, but here's the end of the amplifier in the case. And one other change to let you guys know is this is not the finished heat sink. Nope. These are laser etched. They will be engraved with an actual badge for the Warhorse. So they're going to look even cooler when you get them. So I'm going to hand my computer over here to Joe.
I wasn't going to tell them about that.
I want them to know everything because it's going to be worth waiting for.
So amplifier, no plastic on this amplifier, guys, right? This is basically cast aluminum all the way from one end to the other. There's 4 computer-controlled fans in here, so
versus one
in that one. What you'll see with this one, though, is the reason there's 4 is we can keep the fan speed down so it doesn't make as much noise. It's also computer controlled, so we PWM control the fans.
The speed of the fans.
So it allows us to control the speed with 2 things, not just temperature, but we also look at power being pulled. So if your amp's getting slightly warm, we'll probably pull them on real slow. But then if you go crank up the volume, start pulling, 4,000 watts type of stuff out of these things, we're going to pull the fans up to try to keep the temperature down low. The minute you roll the volume back out, the fans are going to come back down to maintain a lower temperature. The advantage of that is, like we were talking about, FETs get hot, electronics get hot, the RDS goes on. We're going to try to keep everything way cool. So these amplifiers normally when they're running, like you can just, you can lay your hand on them and it won't be a problem. Right? That's really our goal with these, try to keep the temp way down. Plenty of mass, plenty of air. Even if we didn't have fans, they don't overheat. These also have thermal control in them, so they can pull back if they ever need to. We haven't ever been able to get them to do that, not even in
Tell
the
them what you
lab.
mean by pulling back.
So these have thermal rollback in them. So if you got to a point where the amplifier was hot enough that it was going to overheat,
If you're beating the living snot out
it
of
will,
it.
and this is a very intelligent pullback. It'll literally pull back 1 dB at a time until the temperature balances. So instead of like most thermal rollbacks are preset, so they'll go like 25%,
yeah.
25%, 50%, right, or 30%. They get down to like a quarter of the power to balance. With this one, it's completely linear. And so if you're making, say, 4,000 watts to make it an easy number, and that's overheating the amplifier somehow, although that we haven't seen that. Maybe you have a blanket on top of it, or whatever the case may be.
Shut up in the back of a vehicle
yeah,
with the sun beating on
we will
it.
then pull the temperature back to whatever the thermal equation is of what we're able to dissipate. So if we're able to dissipate 3,600 watts, we'll pull back to there and just stay there. And as long as it doesn't keep rising, that's where it'll stay. And then once the temp starts to drop, we'll start coming back in with the rest of it, right? So these amplifiers are made to basically never shut off on you, right? So as long as you don't hit under voltage or over voltage or blow a speaker up, the amplifier should never turn off.
Kind of like those cruise controls that just lock in behind the car.
Yeah,
and adjust your speed.
adaptive cruise control, right? It'll just keep you behind the people and going.
So it's very smart in the control of it.
Yeah, and the way it controls. So if you're looking here at the end of the amplifier, you'll also notice that, of course, there's 2 grounds, and they're split from each other, right?
I don't think they have the...
No, they don't have the amplifier up right now. Let's see if we can pull the end of the amp
There
up. There
we
we go. All right.
Courtesy of my wonderful Galaxy phone.
So we'll notice here that you got the 2 grounds, and they're on the outside. This is confusing until you get used to it. I will say that. But the reason for this is, once again, the symmetrical design, right? This is the most efficient way to run a ton of current into the amplifier through the power supply to get to the other side. And so you got 2 power supply feeds on the inside, 1-aught inputs. They're actually made just a little bit big to make it easier for you to put your 1-aught wire into it.
That is a frustrating thing.
That has been my complaint for many years, and so it's finally a little bit bigger. Thank you, Bill.
Something else is interesting. You're talking about just goofy little things like the power wire input. All of our amplifiers, from the SS and the SI, the ground was always closest to the outside. And even with this dual input, the ground is still closest to the outside.
Yeah, it does.
So it's following some sequence.
It does follow kicker spec. It's just doubled, right?
Mirror imaged.
And the reason the ground's normally on the outside is for the same reason, right? Is the power path is the hardest thing to distribute through the amplifier normally. And the ground is quite a bit easier because you can even ground through the chassis of the amplifier if you need to, right? And so the power is always the important thing. So it's always normally centered so it can get in and then get distributed out to stuff. And in this case, of course, they're mirrored. So I will say this now, and a disclaimer. Please, please, please hook up both sides.
Yeah.
Please, it will work without it, but it's not going to work well without it. This thing draws a ton of current. It's efficient, but it makes a ton of power. And for it to effectively distribute its power in the split rail setup that we have, you need to hook up both sides. So
and use
please
good wire.
Yes.
Oxygen-free copper. Don't use copper clad. You've heard the story and the gripes.
All right, you got the other end, John?
I sure do. I'm not sure which way the other end went, but it. Well,
no,
that's cheating. Don't look at that picture, guys. Yet we'll talk about that in a minute. Oh, if I push the right button, we got all kinds of pictures.
Yeah.
It's hard to do this when you're not next to the computer.
I need that mouse.
Yeah. We need to go.
We need to go way the other way, I think.
There it was.
All right, so the other end of the amplifier, if we can pull this up.
And yes, we're going to show you the other pictures again.
As John talked about, right, we got the dual They 4-gauge, yeah, they're 4-gauge, dual 4-gauge speaker outputs. So you can wire up each one to wherever you want to go, right? Plenty. You might notice in this case here, this little locking tab that goes around the remote base. We know we've heard some complaints that the 3.5s, right, sometimes can come undone and people don't like them, because they don't feel like they lock tight. So we've actually tooled our own specific 3.5 for this and a locking tab that literally slats down over it, and then you tighten the 3mm down and it'll hold the 3.5mm in both ends.
Now, if you guys just heard that, 3.5, connectors are, there's billions of them out there. We actually took the time to tool our own to make sure it worked properly. So, yeah, we're thinking of you guys.
We listen. And then, of course, you have some of the typical stuff you see on a kicker amplifier: input stage, output stage,
that
daisy
volume
chain
control
to another.
labeled gain, right?
Yeah, you got the good old volume control knob labeled gain. You have a low pass frequency, a subsonic on and off on this amplifier, input level, high or low, like you always see on ours, a comp mode button.
Now that's the cool one.
That one's new, right? And then DC turn on, right? Are you using speaker level into the amplifier, or are you using normal 12 volt in for a turn on? So let's talk about these for a second, right? Gain, pretty typical kicker amplifier, 125 to 10, 250 to 40, I believe, on these.
40 volts, yeah.
Yeah.
So
it gets
up to 400
volts,
watts
yeah.
right into the RCA.
Yep. And so in this case, right, you can pretty much put anything you want into the RCAs. They're fully differential balanced. Speaker level, RCA level, doesn't matter.
So you could use a 400 watt amp as a line driver.
You could, yes. You could take an IQ 501 and use it as a line driver. There you go.
I've actually done that.
Low pass frequency, of course, fully adjustable. That's variable from, let's see, I believe it's, 50 to 200 hertz.
Yeah, that should be our normal.
And the subsonic can be on and off. Of course, on is our typical
25
hertz.
24.
Off actually goes down to 5 hertz. Because with the Class D amplifier, you have to have a subsonic no matter what. So it's just way down out of the sonic range. And input level, we talked about that. Comp mode. So what does comp mode do? So competition mode was basically brought on by talking to all the competition people and seeing what they really wanted in their setups, right? What would be helpful? We heard a lot of things talk about gain creep.
Winning would be helpful.
Well, winning would be helpful. But we've heard a lot about gain creep, crossover creep, like stuff moving when they don't want it to move, right?
Well, there's a lot of pressure, a lot of vibration going on in these vehicles.
Oh, yeah.
If you're talking mechanical stuff, I mean, it can
amazing.
play havoc with it.
And then being able to match amplifiers, right? Because you do talk about like half bridge amps. I can strap them, and then, one of them gets put in, secondary mode, and one's the master, and
a slave.
The one gets to control everything, right? Well, all you're really doing is making a full bridge amp with that. So if you need more power, in this case, you talked about running 2 amps to 1 woofer, right? You can do that very simply by putting them in comp mode, because what comp mode does is set all the inputs to 4 volt sensitivity, so they'll all be matched. The crossover is fixed at 200 hertz, so you can use, this is normally designed to be used with a DSP, right, if you're running multiple things. So you can do whatever you want. It's going to be out of the way of what you're crossing over. The subsonic switch will still work. So if you need a subsonic, you can turn it on or you can turn it off. The other thing that we do is we allow a little more, and I want to say this softly, right? This amplifier is stable. This amplifier is start-stop compatible. So this amplifier will work from 6.5 volts, all the way up to...
You just said that, right? You didn't say that this will work at 6.5 volts.
It will.
Probably not make rated power.
It will not make rated power unless you can get a ton of current.
But it's not going to shut off.
But it's not going to shut off, right? And so it'll work from 6.5 volts all the way up to, where's it at? I lost it here. I think it's 16. And so when you get to 16, the amplifier will shut off. If you're in comp mode, because we know there's a bunch of lithium setups out there that charge higher than this and have some issues, we bump that up 1 volt to around 17 volts. Now, like with everything in silicone, there's going to be some variance to that from amp to amp, but it's basically about a volt different when you put it in comp mode. This will allow you to play in some higher voltage systems that you need to. Also, of course, it'll play in low voltage systems.
Yeah.
If you got some 9 volt stuff you want to put an amp in, hey, this one will do it.
That does take a lot of engineering to get it swing from 6.5 to 17 volts and still be a good amplifier.
It does. The biggest problem you come into, and it's what everybody's fought with the new start-stop vehicles causing problems, is the Class D controllers all basically go into what's called brownout mode, where they lose control at about 9.5 to 10 volts.
That's not what happened when I have brownout.
And so, so in this case, though,
totally
when a Class D controller browns out, anything can happen. Your FETs can short together, they can open closed, the chip itself can die. And so you really don't want to get into that mode. So that's why most amplifiers shut off at about 10.5 volts currently.
That's why all of our amps have low voltage cutoff.
And so then all of our new amplifiers, right, the stuff that's made for start-stop, there we got two types, right? We got compatible to start-stop and then made for start-stop. Compatible for start-stop, we've pushed that low voltage down to around 9.5 volts. Yeah. The made for start-stop is all 6.5, and this is made for start-stop, right? It's literally designed to work with start-stop vehicles. We probably didn't need to do that because I doubt there's going to be to it. But there's probably going to be a bunch of people out there with a new Chevy 1500 that want four tins under their back seat when they raise it up and want the power, right? And so this will work with that vehicle when it stops, right? You won't have the dropout. So that's kind of the whole goal.
You get the people doing the death match, 5 minutes.
Yeah. So it is made for that.
Everything.
So that kind of gives you that, right? Then you also see this diagnostic connector on the end. So let's talk about the diagnostic connector.
All right, let me see if I can do this from over here, see if I can pull up the first guess.
Yeah, there you go.
All right, pull up there you go.
So there's the diagnostic piece, right? So this is basically all machine metal. It's a beautiful piece. It's all laser etched currently and buzzed edged. It mounts to this top metal plate that you see here. I'll show you live here in a minute. The top comes off. You can screw it in wherever you want, and it's magnetic. So you can snap it up there. If you want to take it down and move it, take it out of the vehicle or whatever you want to do, you can do that.
What I thought was interesting, you being a car guy too, if you got a metal dash, like some of those 60s cars, you just snap it on to you wouldn't even need the plate. You want it.
Yeah. So this is magnetic. It's held up by some neo-magnets. It's pretty cool. It's really strong. But it does some stuff for us, right? So obviously you can see the 3 digits there. You're going to assume that's a voltage gauge. That is what it is. But it'll do a couple of things that most voltage gauges won't. One, most voltage gauges average over about a half-second time. We originally wanted this thing to be completely live, but we found in the real world that is really, really annoying.
It's very hard to read.
It bounces and jumps way too much. So what we're doing is we started to average, but we're averaging less time than what's normal. But then we also put in 2 modes. We put a high voltage mode and a low voltage mode in. So basically on every ignition cycle of this thing, it will record whatever the lowest voltage it's seen and whatever the highest voltage is seen for that ignition cycle until you turn it off.
That's pretty cool.
So if you're playing down the road and all of a sudden the amp shuts off or something doesn't sound right, you can literally hit the button and it'll cycle through what's currently the voltage, what was your high voltage, and what was your low voltage non-averaged. So even if your alternator lost control, the diode bridge went out and it went up to 18 volts for a second and came back, you'd see that on here because we'll show it to you. Even if you wouldn't have seen it live, the chip will record it and show it like a scope would.
Even if the amp goes into protection, it's not going to erase it. It's going to disconnect
not
the
until you turn power
and shut it off.
The other thing this has power supply, PS, which is the power supply protection. If that comes on, the power supply has been tripped for some reason. So it'll tell you what
not going to come back out of it.
Probably not. That's usually, not always catastrophic, but if the power supply trips and then trips again when you keep turning it on, you probably have a blown woofer or your output FETs are blown or something like that, right? And the last one is amp, and that actually is the Class D output stage. That is the protection for that. So with this, if you are having problems in the field, it'll be real easy for somebody to, 1, diagnose what the problem is, and 2, let us know so we can try to diagnose it with them and help them fix the problem. Or when we get the amp back, we know what happened, so we have a good idea where to start,
where to look.
Make it faster for the turnaround. So that is kind of the quick features of that part, right? There's also another part, of course, that connects to the amp, and that's the bass knob remote.
Actually, tell about the temperature LED.
No, the temperature LED. Cool. Yes, okay, there is the temperature LED, and that is kind of cool.
I like lights.
So that's a 3-color LED. So in normal temp, right, normal operating temp, it'll be green. Do I remember the levels at?
It goes up to 70 degrees.
Yeah, I think it's
70 to 85 is orange.
Yeah,
if I remember.
Yeah, so 70 to 80 something is orange, and it might be 82 or 85. I have to go back and look. Will be orange, and then red, of course, will be over that number, right? You should never see that. If you do, you need to get your amps some air somehow, because these don't get that hot. We are playing them here in the building on a resistive load for torture tests, and they won't even hit thermal. So we can't even get them to get orange, right? They won't get there. You can put your hand on them all day long. They're like 55C. So you should probably never see that light change color, but if you do, let's talk about the install.
If you were at the showdown like I was in Prim a couple weeks ago, I mean, these guys are packing, 40 amplifiers. And,
they stack them up on top of each other, right?
And then they shut them in the back of the tailgate of the van, or, and they get no air, or if they leave them in the back window or the sun's beating on them. It's like, but they are going to cool much better than probably anything out
these
there.
will cool very well. I wouldn't care kind of what you put in. Unless you're like throwing blankets on it and like making the fans not able to suck any air, then maybe you might have a problem. But you should never really see thermal with these. But if you do, right, if you have the dash display hooked up, you'll know when something's getting ready to happen.
That, and you won't need those big, really noisy marine fans that a lot of the guys are using. They look like little jet engines.
These things
are about as loud.
These things are quiet enough that you can mount them under the seat in your Tahoe, and you won't even really notice it, as that's one of the vehicles we have one of our long-term testers in, right?
Chase, you guys remember that?
Yeah, and you can't really, you don't even know it's there.
We shouldn't tell him that we actually hooked that up to his quad box.
Oh yeah.
Man, it was loud.
Yeah, the quad box got at it with us.
Yep, it stretched its legs a little bit.
It did. So I think we can turn these on and we'll maybe show you a live shot of how these work. We'll kind of show you how the voltage works and all that different stuff.
Let's go ahead and pull the laptop up one more time.
What do you got? You want me to talk about?
Show them the other picture. I think we were. See.
Just use the arrows. No, there's nothing more that way. What'd you break?
I'm not an arrow guy.
Where are your arrows?
It should be over there.
Should be, but it's not. There it is.
It's because it was still zoomed. There's the control.
There's the bass knob.
So a little close up of the bass knob, and it's all machined with the magnetic.
So once again, all machined, metal knob. It is notched, so you feel a notch every time you turn it. So it's nice. Feels nice. Looks nice. Once again, magnetically mounts, so you can snap that up and put it wherever you want. And then take it down and yank it out of the car if you need to be able to control outside the vehicle if you have one that can do hair tricks or whatever you want.
It's also got two other cool mounting options too, which I think is unique.
No, that's right.
Where you can actually through mount the potentiometer. You pull it out of the entire case if you want. Or you can actually leave that little machined faceplate on there and sandwich that control, because the screws are ultra long. So we made it so you could actually mount the whole thing as one unit just by drilling a hole and taking the front cover off.
And that actually applies to the display as well.
Well, see, I just learned something. That's cool. Yeah. Now I want one.
Well, I kind of forgot about that feature until you brought it up.
All right. Well, I think we're done with the laptop for a little bit. So if you want to go back, Joe can show you actually these magnetic tops. If we go back to a big shot, there we are. Big shot. That's your middle name, isn't it? Hey, it's on.
So you can see the top here, right? Pulls off, magnetizes back on. I don't know if you guys can quite see unless we zoom in on this display, but we can get a zoom in, and then we can have John show a couple options here. We can get somebody up here to zoom in.
The amplifier mic. Yeah, if you guys got it on a TV,
you might be able to see that.
Put it out a little bit closer where to get it actually in focus. See, actually, it's running 15.1, 15.2. So you can see it. It has got a fairly high sample rate. And by the way, guys, this is the first time I've seen this control lit up. So I wasn't even sure what color the LEDs were.
And this is much slower than real time. Like if we make this real time, it's so annoying you can't watch it. So we've slowed it down to a point where it's fairly reasonable, but it still allows you to really know what's going on in the vehicle. Unfortunately, everybody thinks like what the meter sees is the real voltage, or whatever the display sees is the real voltage. But it's usually 2 or 3 volts different than that is actually what you're really getting in real time.
Especially with some of those, like spikes are so quick that those meters don't even see it.
Yeah. Meters actually average somewhere around like half a second of voltage, and so it's hard to really see anything that's a spike or a dip. You just get the average kind of going up and down a little bit as it averages over time. And so, an O-scope will do that. Of course, the faster the O-scope, the faster the spike it can see, but that gets expensive and hard. They're not as easy to use. So we wanted to give somebody both options here. So if you can see here, so you should be able to see, what can we get? I don't know if they can see that or not, can they? Anybody got a comment over there? Can you guys actually read the display?
I can see it from here, and I have troubles reading the screen.
All right, there you go. That's pretty good. All right, so if John goes over here and cranks this meter down, right? The power supply.
Voltage or current?
Turn the voltage down to like 6 volts or so.
I'm turning the voltage down. Look at it. Hey, I know which way down is.
Yeah. And so you saw a light change down here. That was telling us, hey, even though we don't shut off till 6.5 volts, we will warn you at 10.5 and like, hey, something's wrong.
Let's go back up and do that again.
So you go back up, you notice those two LEDs changed?
Yep. Oh,
Yeah.
you see that bottom LED came on? Now we're going to go down. Let's see where it shuts off. Cannot believe this thing's running this low.
Oh,
There's
there we
Bill.
go. There's Bill.
Thanks,
saving the day.
Bill. See, Bill does do other things other than type. Is it off?
Yeah. Yep. Hit protection.
Yep.
So as you come
there it
up,
goes.
there's
So
low
yeah, about
voltage back
6.5.
on. Off you go. The amplifier's
That
making
is
power
pretty impressive
again.
for an amp that big.
Now, what's kind of cool about all that, though, is if I can find the right button here. Let's see.
It's backwards if you're watching.
So there's low. 6.1
6.1
was the low that we saw. Here's high. 15.3 is the high that we've seen. And then it goes back to voltage a second later. And so to let you know where you've been.
That's just pretty cool. I like it.
And of course that, and then of course there's your close-up from the bass knob. Bass knob has, of course, the same locking tab as the other side does. You notice they kind of match together. You know, we had some intentions of somebody maybe doing this in a display board or whatever you wanted to do, right, to where they're identical, slotted together, but they can be mounted via magnetics. This can actually be pulled off and turned any way, so if you need to mount them from the top down, you just turn the housing to where you want it, put it back together, magnetize it down, or you can pull the two screws out of the back, like he said, and just use the front face, sandwich the back onto it, or you can just take the knob out completely and, you know, custom mount it.
Snap one of those top pieces for him, show him. I know there's some pretty strong magnets.
You guys got any questions we can go to?
Yeah, I'm sure that people have probably got all kinds of really good questions. And
need a
I
drink.
apologize, I've not been watching that up there for the most part. But something else I'm going to ask you real quick, Joe. We've talked about the Class D, the switching frequency. How important is that? In an SPL amplifier to have ultra high switching free. And what is it? Isn't it 100 plus?
So the switching frequency gets you a couple things. One, the first thing is the higher the switching frequency, the higher the frequency your amplifier can play, right? So, I mean, if you've been around long enough, right, the first Class D amplifiers supposedly played to 200 hertz. They didn't really even get that high.
And they didn't sound very good at all.
And then the first full range amplifiers Infinity came back out with way back in the day, played to 5 kilohertz. They called them full range, but at 5K, they went like that, real steep, right? They didn't sound very good either.
Wasn't the rule of thumb 10 times higher than the highest frequency?
And that's like cutting it close, right? So if you want to play to 20 kilohertz, you need to be switching at 200 kilohertz, right?
200,000 times a second.
And that's the minimum to have enough samples to play at 20K. If you really want to play at 20K, you should be switching around 300, 350.
Almost
right?
double that.
Because then you get more samples per sine wave to get because the way I don't know if we really want to go into how Class D really works, but you're taking a triangle wave, you're referencing audio to that triangle wave and rectifying it. So the more samples you can take, it's just like an MP3, right?
Yep.
Can I get 128?
Resolution.
Can I get 256? Can I get 3, 4? Like what is the resolution where it starts to sound like it's supposed to again, right?
Now, typically the other brands, what are they sampling at?
It really depends on the Class D controller.
Throwing all these questions that you were
That one's wiped, so it's hard to tell. Each Class D controller has its limits, right? So like a 2957 is the most popular sub-Class D controller, at least by the name brand people, right? There's some Chinese knockoff chips and stuff, but as far as name brand Class D controllers, it's a 2957. And I'm not sure the number off the top of my head, but I would expect it'll let you play out probably to about 1200 hertz or so. So it's switching in the 150s.
It's still a subwoofer mid-range.
It's still a subwoofer mid-range amp. Yeah, because they have like a 2092 is a 2-channel Class D driver for a full range amp, right? And a 2093. And so, but you can make a subwoofer amp with a 2093 or 2092. You just have more channels than you typically need in a sub amp. But if you're running a full bridge sub amp, right, 2 channels, well then okay. Then you want to use one of those, or you want to use 22 2957s. And so it really depends on your design and your application. There's a lot of subwoofer amplifiers out there that could probably be full range amps. Nobody just bothers to because there's no point. So you just leave your high pass set in. You don't make a switch. You take money out for the switch, and because who's going to put 2,000 watts on a mid very often, right, or something like that.
You haven't met these guys.
Oh, I know. There's some of them. So,
I know you're out there. I saw you guys.
I've met a lot of them. Not all of them, but I've met a lot of them.
All right, last question on this before we get into some of the other questions.
Okay.
Input impedance. And why is that important, especially for multiple amplifiers?
Input impedance is usually important depending on what you're driving it with, right? So if you're feeding a stereo chip panel of speaker outputs out of a head unit to the amplifier, all right, input impedance probably doesn't matter. But if you're using RCAs or low level, input impedance becomes very important. And there's a couple reasons for that, right? So most RCA outputs will be, so let's just say 1 volt to make it easy. Most of them are 1.5 volts now. They say more, but in general, they're about 1.5 for this.
1 volt's easier for this.
Yeah, we'll do 1 volt, makes it easier. So say you have 1 volt output. Well, the problem is you have 1 volt, but you have very little current. And impedance is what causes current to be pulled. The advantage to current is it's easier to get away from noise. RCAs, to be honest, are probably the worst way you could carry audio in a car. But we started like this in the 70s, and we've never been able to get the industry to change.
We started with DIN cables in the 70s.
Yeah, but it was the same signal.
Yeah.
We didn't change the signal, right?
Just the way it was grouped.
A single-ended low-level signal is a terrible way to carry audio in a car. Why do we do it?
And then you tie it to the chassis ground.
Yep. That's because how audio was transferred in home, right? And so we just stole what was there, and that's what everybody's used. I would love to get away from it if we could get the industry to change, but it's just a very bad way to
help us with that,
signals.
guys.
But with that, right, you have very low voltage and you have very low current. So your input impedance of your amplifiers, if you go back to the old school amps of the 90s, they were like 100 to 1,000 ohms at best. So what happened? Those old
100 to 1,000.
Yep. And those old school decks only put out 125 millivolts. So what do you think the amplifier really saw once it got divided down by the input stage?
No wonder they didn't sound good.
Little to nothing, right? That's why we fought with engine noise forever back then. I was an installer in the 90s. Like it was a nightmare. Fast forward a ways, right? Everybody on the amplifier side realized, oh, well, that's probably not the best thing to do. Most of us. So what the big guys have done is we're all 10K, 50K, 40K. And with that, you have very little loss from whatever your signal input is to your signal that actually gets into your first op-amp stage in your amplifier. So that's a good thing. The drawback to that is, once again, no current, right? And that's why we've preached for a long time to get more voltage, whether that's going speaker level and knocking it down through like a kiss lock where they barely cut the voltage and just strip the DC off, or if it's going speaker level directly into an amplifier that can take it. There's advantages to that. And the biggest one is voltage, which equals less noise, more audio.
Signal
and
noise.
Your signal noise gets better. It's just how the math works. It also allows you to turn the gain down more. So any other types of noises, like the inherent noise in the amplifier, will be lower because your signal's higher. So your system noise will be lower. So there's so many advantages by having whatever is the front of the system have a lot of voltage, because it will make everything else work better. And that's really why we have these 40 volt inputs on the high level and 10 volt on the low level, right? It's because we want you to try to give us as much as you can, because it'll make everything better for you and your system.
So what is the input impedance on this?
This one's 10K.
Okay, see,
Yeah.
now we know.
Most of our amplifiers that do the speaker level are 10K. They also, some of them will have a load switch. We'll add a 60 ohm load to keep a Class D radio
The amp
happy.
detect button.
The amp detect button. This one does not have amp detect buttons on it because it's not designed for that type of
It's not
environment,
designed
really.
to work with a Chrysler Smart Radio.
Yeah, and so, this is really aimed at a different marketplace, so we didn't burden this with that input. But this is 10K. Now we have seen on some of these other style amplifiers some very low input stages still, which is kind of funny because I think everything comes naturally. Like somebody was into car audio in the 90s and they had some circuits and they built some and they got into it and they started building amplifiers because that's what they loved, but they copied what they knew, right? And so in the time, unless you're doing a ton of engineering and real world testing, you don't really understand the application has changed or why you did something, right?
Yeah, the fact that head units don't have preamp outputs anymore.
Some of them, a lot of them don't. Although some of them are coming back. It's kind of funny. They've made a switch back to actually putting real preamps in a lot of them.
Which is not a bad thing, but
But the other thing that people don't understand is like this side you want the high impedance, right? But But on the other side,
the head unit,
you want the lowest impedance you can because that means
100.
it can supply as much current as possible, right? So if you can get down to like 100 ohms of output impedance, you can supply a lot more current at that 1 volt than you could if you're a 1K output at 1 volt, right? Your current's going to be much less. And that's important. They both go together. So it's important to be able to have a low impedance, high current source, and then a high impedance input. That'll make for the best you can have. And that's why speaker level is actually a really good input for an amplifier.
And it didn't used to be.
It didn't used to be, but there's also some drawbacks.
There's evolution.
There's some drawbacks to that, right? Because it's all application based. If you have a new factory radio that has a Class D radio, well, it's going to need a load, so it's 60 ohms, so you will create some heat and you will get some drop, but you're still going to be way higher than you would be if you were taking RCAs out of something, right? And so there's always everything in the electrical world is give and take.
There's that gray area in between.
And so unfortunately, physics can't be broken; they can only be bent. So no matter what you're doing, you're going to end up answering to them sooner or later.
Cool. Well, I think we got. I know we had a question up there a minute ago, something about comparing this one size-wise to the new Warhorse, and we're going to take some of your guys' questions before we take another break and go, because we still got stuff to give away, guys. And by the way, if I didn't mention it, which I'm sure I didn't, that's why I'm remembering to mention it now, we are going to give away another Term Pro tonight. So one lucky winner is going to win another speaker designing package. So question for Joe, the new Workhorse, we're going to call it a Warhorse, is how much, that's spell check, I'm sure, how much smaller in a percent? So 40%, 35?
60, it's probably 60-ish. I've got the Warhorse on my desk, and it's the size of this table.
Yeah.
Yeah, so literally it's...
Not, yeah.
Yeah, it's like that big.
Yeah, it's 38 inches.
Yeah, so it's,
it's 68 pounds, too, by the way.
Yeah, it's 60-something. I can tell you that for sure when I pick it up over the wall. So that one is about this big, right? So looking percentage-wise, it's probably 40% the size of the original Warhorse at this point.
So good question. And 15.5 to 16 volts from Brad Manning. Good old Brad right here in Stillwater, Oklahoma. Thanks for watching, Brad. Plus rated amps in the future. He's probably thinking for those electric vehicles. So
of course, if you worked on electric vehicles, the new Teslas are 15.5 volts, right? They cause a pretty big nightmare with most common 12 volt, 14
But how high is the alternator charging?
There is no alternator.
The alternator.
There is no alternator. There's a 4-channel PCM that has 4 or 5 outputs that apply different amperage out to different parts in the car to keep everything safe.
So when you plug it into the wall, how much higher is the voltage?
Yeah, not at all. Not at all.
Good question, Brad.
It doesn't flex at all. So what you do to deal with those now, if you haven't had to deal with one, or if you're trying to figure out how to deal with one, is you can use either a voltage regulator, you can buy them on Amazon, or if you can find a battery isolator that uses diodes, which there's 2 types now. The diode will have a 0.7 volt drop. What you normally do is put a small lithium next to the stock battery, put the diode isolator on it so it charges the lithium and it goes out to the amp. You're at 14.5, 14.6, everything's happy. But the biggest problem is if you draw a bunch of current from the stock battery or the stock charging system, the car knows. It's smart. And it will literally either shut the car down or put trouble lights up and make you go to the dealership because they monitor all those outputs. There's, like I said, there's 5 outputs. 2 of those outputs go to stability control and ABS. 2 more run the left and right of the car, and the 3rd one's a backup for the safety systems. And so they monitor all those outputs. So anytime you add a bunch of current to them, it's going to cause problems because they're monitoring all that and they'll think it's a problem. So currently, the best way to deal with that, even if you do make an amplifier that works at 15.5 volts, you can't really put it on their stock system. You're going to have to put another small battery in there and isolate it.
I think probably a lot of these guys, Brad's probably talking SPL, knowing what Brad does.
If you're doing the SPL thing, this will work in that car, but the car won't be happy.
Cool. Now,
do it like we did in our Bronco. Make a separate lithium pack that's by itself.
Jeff's got a question here. We'll get to that one right after. Andy had a question. I just saw right below that one. The subsonic is not fixed at 25 hertz. If the subsonic switch is on, it's 25 hertz. If it's off, it's 5 hertz.
Yep.
So.
Yeah. So when it's off, we move down to 5 hertz to let subsonic play. But you still, like I said, have to have some type of filter on the bottom of the Class D amp for switching. And then if you plug it on, it's 25 hertz, so you can turn it on and off.
Jeff Smith asks, what country is the Warhorse amp manufactured in at the moment? Here.
Well, no, we have made some. This will actually be made in Thailand.
And that's actually where our CXA amplifiers are built.
It's also where our CXA
amplifiers. Hey, and if you guys haven't seen that, I'm going to toot our horn just a little bit. CXA amplifiers, of the top 5 amplifiers in the world, the 801, number 1, the 401, number 2, and the 1200 was number 4. So 3 of the top 5 amps were the CXA.
You forgot the 364.
Oh, yeah, that's 4th.
Yeah.
Sorry. But yeah, I mean, just great amplifiers, so.
Yeah, this will be built in Thailand. Jeff knows where I'm talking about, I'm sure. I've seen some stuff that he knows about there.
I knew this question was coming because I had it too, Billy. He says, will the knob work on other kicker amplifiers at the same value of pot?
Yes, it is. So if you want a really cool bass knob for a CXA amplifier, yes, this will be your choice.
Yes, I do. All right, what's it? Will the Warhorse, this is Flexin 500, will the Warhorse be capable of being wired to 1/2 ohm? Well, you can wire anything, I guess.
You can wire it to whatever you want. Depending on your box rise and how you play it, we would not recommend it. But yes, that's application specific, so that's why we don't recommend it.
And, here we go back to that box rise. A lot of people, assume, DC resistance when they're, wiring their speakers, and that couldn't be farther from the
Anybody
reality.
that's doing stuff like that, you really should buy a DAT system from Parts Express and use it. It'll give you a good idea what will happen, whether to be happy or not.
And you remember the good old days of the auto formers? Oh, the impedance curves those things would throw. Just, crazy stuff. All right, another question. Or Joe's been just that good, he's answered them all. Ty Rogers says, will the Golds be in limited production? Initially, they were going to be, but we decided they're going to be basically, unless something tragic happens, they're going to be a permanent addition to the line. They really are really a good sounding speaker, and that it really is kind of a really good homage to the the woofers from '86 for our 50th anniversary. They look great, they sound great, and they definitely outperform a Comp R. I've heard them.
So yeah, some of the listening tests there, they were originally, yes, limited. When they went through listening tests versus competitors and even some of our competitor speakers, I think it was pretty much unanimous. We all liked them better. And at that point, it kind of went from being, a throwback homage limited run to, no, we're going to make these because they sound that good.
Yeah, because it is a better woofer.
Yeah, so I think you're going to be pleasantly surprised when you get them in a box and listen to them.
And if you put it side, we should have done that. We should have grabbed the Comp R out and put them side by side. It's not just a dressed up Comp R woofer.
No, they're different.
I mean, it is definitely different. These things are pretty cool. So, why come out with a speaker that's just different cosmetics and not any better? So that's not the way we do it. If we're going to do it, we're going to spend the money and do it right. So Wade Hensley says, will the Comp Golds have more throw than the Comp R? Yes, they will. More power handling and more throw. So yes is the direct answer. My wife always wants one-word answers because I try to explain my answers and she gets angry. So yes is the answer to that one. 0.5-inch X-Max versus 2-inch X-Max? Question mark from Brian Park. I'm not even sure what he's asking by that. Which is better, a small X-Max or a large X-Max maybe?
Sound quality, probably small, but
yep, and,
output, of course, the longer one, right? Depends on what you're doing.
And it depends on the speaker too. Not to get really, really deep into the weeds on X-Max, but X-Max is just a measurement, and it's not the measurement of cone travel. That's practical X-Max. That's what we call the cone travel. But X-Max is how much the voice coil hangs above the top plate. So if the voice coil is the same height as the top plate, it has 0 X-Max, but it still has a lot of travel. And in fact, an underhung voice coil, like in a high-end tweeter, the top plate will be much thicker than the voice coil, so the voice coil actually is smaller. So technically, that would have a negative X-Max, and it still moves.
So John's digging into the weeds there, because there's actually 2 ways to measure X-Max, and that's where it gets confusing, right? The one way is 707 of BL, and that's BL is the motor
that's
strength,
practical
right?
X-Max.
That is, the practical X-Max of what the woofer will move in control in and out. Now, yes, the woofer will still move farther than that, but that's where we call the woofer will be in control. But there's another way where a lot of companies, because they don't have a clipple, because the only way to get that number is out of a clipple.
And spend 40, 50 grand for one.
So they'll do a math X-Max, right? And so they'll just take the overhang over the top of the coil and the under and do the math, and this is what they'll say it is.
Technically, it's the height of the voice coil minus the height of the gap divided by 2.
Yep, there you go.
And that's just a physical number. So it depends on what number they're using, and like we know with everybody with specifications, there are companies out there that will use those numbers to their advantage. They'll spin them any way they can. One of the companies who's no longer in car audio, but they've made really, really nice home speakers. They make good car audio too. They would measure the sensitivity of their speakers, how loud they play with 1 watt, at half a meter, where the standard is 1 meter. So the microphone's half the distance away. Yeah, it's going to look louder.
There's still some people that do that.
Yeah.
I've seen it. They actually call it out, though, at least. But then, of course, it's hard to A to B it,
people
right?
don't read the little fine
it's
print.
hard to A to B at
1
that
watt,
point.
half a meter. They just read that, 90, especially when you start talking about some of the pro audio stuff, like our ST series. We're talking 94, 96 dB sensitivity on the mids.
Taking you back to the 90s.
106 and 108 on the tweeters. That's loud with 1 watt. Good grief. So, cool. Any more questions? Nope. That is no. I want to give a good thank you to Joe for hanging out with us. I hope you guys learned a lot. If you guys do have other questions, support at kicker.com. Send the guys an email, and if they can't answer it, they're right here in house with us. So that's a cool thing about our support staff is our engineering guys. How many guys are working in your engineering department?
Total, we're like 48.
48 engineers. So they got access to all those engineers. So like I say, feel free to reach out to us anytime. We're always here to help and educate. That's kind of what the whole show is about. So I know I've had some fun, and actually I learned a couple things I didn't know, especially what color the light was. I really wanted to know that, but I didn't want to ask. So we're going to take a break, and then we're going to come back with questions, fails, installs, and then we're going to give stuff away. So stay tuned right after this break. Thanks, Joe. Yours.
Something about your hands on the wheel, got a sexy touch. It's enough to make me and my Chevy blush so long. Take it all off of that highway. Turn me on, I'll let you drive, babe. You can take it fast as you want to. Dirty little dirty looks damn good on you. Start me up, Stones on the radio. Girl, I love the way you let go. Don't waste your way in the wrong way. Get off on some 4x4 play.
We're sitting here on the break, getting ready to do this next segment. Joe looks at me and said, hey, we didn't go long this time. He forgot how much I talk. So, we're not done yet. It's 5 minutes till to the hour and a half mark, but, we go as short or as long as we need to. So tonight might be a few minutes past 9 o'clock Central Time, and questions here. And, we might throw some of these at Joe. I got 3 questions. What is the difference between 2 ohm, 4 ohm, and 8 ohm? James asks. So why
double the impedance? Really, I think the dual voice coils and all the impedances came up back in the day because of different amplifier power, right? And at different locations.
That's back before we could bridge amplifiers.
Yeah, back before you could bridge amplifiers, before you had a bunch of choices. Like if somebody really wanted to narrow it down today, you could really probably slim that down, but it's gotten so normal that everybody has all these options that we've kept it. The reason for dual 2 ohm, right, is you can take a single woofer and get to 4, or you can take a single woofer and get to 1, depending on the amplifier that you have. If you have a pair of them, right, you can get two ohms, which works pretty well with a lot of amplifiers. 4 ohms, kind of the opposite, right? You get 8 or 2, or you can get 2 woofers to get to 1. So it really they're really all there just to match amplifier power. Nobody wants 16, John.
I know. I'm just
nobody
saying.
Nobody does it. Yes, you could get to 16.
4 coils in series, it'd be 16 ohms.
Yeah,
now you're talking
uses
pro
16.
gear.
So, for our world, right, back in the day, 4 ohm was your normal woofer. Like when I grew up, you had a 4 ohm single coil woofer, and then you had then you had 4 ohm dual coil woofers, and that was it, right? And those were your options because all amplifiers were 4 ohm or 2 ohm stable. There was no such thing as anything below that until the high current cheater amps showed up, right?
and all those.
And the Soundstream Class A's, and all that stuff showed up, right? And then, you started seeing some dual 2s. So it really is the impedance is all about matching whatever subs you buy to the best power output of your amplifier.
And that's the key.
And that is the whole key to everything, right? It's about matching the impedance of the sub to the impedance of the amplifier. So if you have a 1 ohm amp, buy whatever subs will get you to 1 ohm, right? And if you have a hard time doing that calculation, the Kicker U app or the Kicker U Lite app will do it for you. You can just punch in what voice coils you have, punch in how many woofers, and hit go, and it'll even show you how to wire them. So there's plenty of tools out there to help you with that if you need help, or you can call our tech guys and they'll help you.
Yep. Or just talking single voice coil. Difference between a 2 ohm coil and a 4 ohm coil. The 2 ohm coil, all things being equal, will play twice as loud with the same power because it's got half the resistance. So, an 8 ohm is going to play a fourth as loud.
It's also
because
lighter.
because it's got less wire. So that's kind of the difference. I mean, it's all the impedance matching up, and if you're just talking straight impedance, the lower the impedance, generally the higher the output for the same amount of power, considering it's the exact same speaker. So next question. All right. Actually, an install question, finally. Is it okay to put a bigger speaker in a door that came in the stock vehicle location? What do you think, Joe? Is bigger better?
Bigger is always better if you can actually get the sound out of the door and not actually not interfere with everything, right? Because normally
the window regulators
you'll have your speaker, the back basket hitting the window or the window regulator, so you got to be careful of that. Then you got to get it sealed up real well to get mid bass, and then your last problem is getting it out the door panel effectively, right? If you had a 5-inch hole and now you put a 6.5 in, that sound is either going to have to get squished down to go through that 5 hole, or you're going to have to modify it, and a lot of times there's an indoor ring on the panel. So if the modification to the vehicle is right, yes, great, go for it. But if it's not, you're better off sealing up a new speaker of the same size and making dynamatting the door and get it well sealed.
Exactly.
That will do better for you
and
than
then
going
the
bigger
foam
speaker.
between the door panel and the metal itself, the fast rings.
Yeah, the fast rings.
I just go buy foam from Lowe's, and that makes a huge difference. If you guys haven't done that, because without that, the pressure from the speaker actually seeps, between the door panel and the door, so you lose some output and you lose some mid bass. But yeah, that's a good question. People ask, but it's not uncommon if you have a 5 1/4, cut it out to a 6 or 6.5. And in fact, what's really interesting is our QSC speakers. They have an adapter from the 6.5 down to a 6-inch, so then you don't have to cut anything. It's just got that nice little step-down adapter. Rambling again, as I usually do. The third question, final question. Here you go, Joe. I am putting in multiple amplifiers. How do I determine what fuse and how many I need? Now, what fuse are you talking? What type of fuse or what value? Because if it's a marine application, you need a sealed marine fuse like the MRBF.
Yeah, so depending, marine, is a unique situation. If you're putting a fuse in the engine bay, in a marine where they're sealed, yes, you need to use sealed fusing because you don't want to burn the car down when the fuse pops, right? They're bad. But in the general application here, right, you're going to have a power run from the front to the back or wherever you're putting your amps. That needs to be fused to match the power wire. Whether that's a 4 gauge with a 150 amp fuse or it's an 8 gauge with a 200.
Because that fuse is there to protect the wire.
That fuse is really there to protect the wire from burning your car down if somehow you short it. Really, that's what that fuse is for. Then when you get back to the back, you should put in a distribution block that's fusible, and those fuses should match the wire and the amplifier. So if you're going 1 foot with 8 gauge to 1 amp, and it's takes 100 amps of current, that should have a 100 amp fuse. You're going 8 gauge over to your mid amp, that needs a 50 amp fuse or whatever that matches the recommended call out from the manufacturer in the amplifier. And those fuses are really there to protect that little piece of wire, but also to protect that amplifier. If something catastrophically happens, that fuse will open up before that amplifier will be able to get hot enough to actually burn the FR4, which is the PCB board, and cause fire. We've seen a lot of installs where somebody will take and drop a 300 amp fuse up front, take it to the back, distribute it with smaller wire, and no fusing.
After that 300 amp, yeah.
Yeah, and so one of those small wires gets shorted or the amplifier shorts.
It becomes a heating element.
The wire becomes a heating element real quick, melts, usually catches the box carpet on fire because that seems to be where the amp's mounted. The box carpet melts everywhere. The amplifier melts down because there's no protection, because the 300 amp fuse is more than that amplifier board can take and heat. And so you just burn holes in that board. But the bigger problem is the wire melts, which causes stuff to catch on fire. Yeah. And so you really need to fuse each stage, and I think that's something that in our industry we're not really well understood in a lot of cases. Right?
Anytime you step down gauge and wire, you need a fuse. Yep. Period. I mean, doesn't matter if you're going from 1/0 to a 4 gauge or a 1/0 to a 10 gauge. You need to have a fuse where it's stepped down.
No, the best is where it goes like 1/0, 4 gauge, 8 gauge, and then a little 16 gauge wire over here to run an LOC or a processor. And
or you get the guys putting the screw through the power wire, for the remote lead.
Yeah, I've seen that.
Power. Yep.
Just screw it down.
Lots of electrical tape.
So. So I mean, you're really trying to protect the wire, but it is the final fail-safe for the amplifier as well. And so you really need to take both into account in all applications.
Cool. All right, well, that's going to be the questions we're going to answer for tonight because we're getting kind of long in the tooth, or I should say I am. I think, it's about ready time for some fails. Let's look at some good fails. Come up with 4 of them for this week, so let's see if I can get them to pull in off the cloud. So, that's a fail. I don't know if that's just corroded or, it's obviously rusty. And no paint scraped off, under that connector. So I'm going to have to give this grounding attempt, maybe a C or D for effort and an F for effectiveness.
But the second screw keeps it from moving.
What was that, Ernie? Is that what that is? It's soldered?
I think that's corrosion.
That's corrosion. You're looking at a small version. That's corroded wire.
But that second screw keeps the thing from turning, though.
You're right, it does. So that's probably the only thing that second screw is good for. So the next one, thinking of my days, going with all the people with their bi-9s in the back windows.
Infinite baffle, baby.
Yep, most of them were, just literally just sitting on the magnet facing straight up.
Yeah.
So, the whole purpose of a speaker is to isolate the front wave from the back wave. Now, this has probably got great high frequencies from the rear, which if you listen to my, imaging and staging speech about no mid and high frequencies from the rear, it's, okay, this is wrong, guys. This is a fail. And I don't see that they're bolted down anywhere. So you get in an accident, you're going to have a bi-9 up the side of your head. Or embedded in the back of your neck. So, yep, definitely fail on that one. And, if we're going to talk, crazy, we can't even get the wire strippings, out of that before we took the picture. But that's a lot of self-tapping screws and a lot of grounds in one kind of, I don't know.
So, that's 3 wires on the left tied with 2 screws?
I don't even know. Let's zoom in on it
like...
and see what we can see here.
Yeah, there's a third wire. So you got 2 held by the
1, 2, 3, 4, 5, 6, 7 wires grounded, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got a surplus of self-tapping screws. But
nice.
Yes. Come on, guys. I know you can do better than that. And like I say, if any of you actually did these installs, this is all for fun. Hopefully you're learning from this show by seeing these pictures. Don't do that.
Oh, if you saw my stuff from the 80s, I would be very embarrassed.
I got to admit, too, I've done some things I'm not proud of. But this is really interesting. I don't know if this is a second alternator or what it is. But, the reason I pulled this up, because you talk about SEMA, all the people you see at SEMA. I got to see a lot of people that I hadn't seen for a couple of years. But I ran into one of my friends from my hometown of Lincoln, Nebraska, Doug Killian. And Doug used to make shortened Thunderbirds, like the 88, 89 Thunderbirds. He'd actually cut 1.5 foot out of them and shorten them. They're actually pretty cool. But I ran into him at the show. I hadn't seen him in probably 10 or 15 years. But he was working on a car with one of our buddies here in Stillwater, Rick Kirk. When Rick was live, the guy wanted the alternator on the drive shaft of the car. So they were working on building a bracket to run the alternator off the drive shaft, which is great while you're driving down the road. But when you're setting at stoplights, you're not charging anything. So, it's kind of a cool, funny thing, but it's probably not going to be anything that I'd recommend. So we did the questions, we did the fails, we did the installs. What's the last one up there, Joe? What's next?
It's like giveaways, John. What are you giving away?
I think it's time to give away stuff. Bill, are you ready to give stuff away back there? I think that was a yes, and someone was trying to buzz me here on my phone. That's Kendall Claybaker. Kendall, we can talk to you later.
Answer the call.
Apparently, he doesn't watch YouTube or Facebook. Anyway, and I know he doesn't watch either one of those. Kendall used to be one of our regional sales managers here, and Kendall, we love him to death, but he's probably the most OCD guy you will ever meet in your life. His garage was carpeted. It looked nicer than most people's living rooms. But anyway, enough about Kendall. Let's give something away. Third prize. Who's going to win the third prize? That's going to be the EB400s, the koozie, and the Great Kicker t-shirt. And that's going to be Richard D. from Kansas, just north of us. So, that's, when I was growing up in Nebraska, that was the big thing. It's like, how do you get to Texas? Well, you drive south till you smell, cow crap, and then you're in Texas, and you keep going till you step in it, and then you're in Texas. So, anyway, but Kansas, so thanks, appreciate it, Richard. Thanks for watching. Watch for an email from Bill Frog. He's going to ask for your name, your phone number, your shipping address, and, of course, your shirt size. We got to know that because we can't tell from your registration how big a shirt you need, whether you need a manly man or, as Kip would say, a schmedium. Yeah, I can't wear. I don't think I ever wore a schmedium. All right. Second prize winner is going to be coming right up from Bill Frog, James K. from Missouri. Got all these Midwestern states. James, once again, look for an email from Bill Frog with your. He's going to ask for your name, your address, your phone number, and your shirt size. So, grand prize winner for tonight. Joe, you want to go ahead and tell them who the grand prize winner is right up there on the screen?
If I could read that, I would. Let's see. Great. Stephanel from Louisiana.
Yep. It's kind of all grouped right here, kind of in the Midwest.
Yeah, Midwest people
so
tonight.
Congratulations. You get those Cush
Stephen.
NCs, and we forgot, Richard wins the Tabor. So that was the second place with the Tabor. So y'all get the koozies. Y'all get the T-shirts, whatever size you happen to need. And then, of course, the third prize is going to be the EB400s, which are the wireless Bluetooth earbuds that are water resistant. You get the Tabor headphones, which are the Bluetooth over-the-ear headphones, which can be used as normal headphones. And the grand prize winner gets the Cush NC, the noise-canceling headphones. And, man, I sure like mine. And
Do we have a Turn Pro to give away?
I got to say, I think we got one more thing. Don't we, Bill? We got something else to give away? We do, he says. Are you ready for this? We're going to give away another Term Pro. That was from our good friend Wayne Harris. This is the box building software that we use right here in the building. Now, I will say that our acoustic engineers, they write their own. I mean, these guys are they're out there, so they know specifically what they want. So they've written their own software, which is really amazing if you've never seen it, which I'm sure you guys haven't. But it's really, really good
And really consumer easy to use.
Yeah, no. You can't. These guys aren't consumer friendly to talk to. You get a dissertation, in broken English. Anyway, so Joe, why don't you tell them who's going to win that final? I think this is the second one, not the final.
This is the second, the second Term Pro. We got one more still.
I've been gone on a couple of these shows. I don't know what
let's
they do
see. And the
when
Term
I'm
Pro
not here.
winner is Hogan Y of Pennsylvania. There we go. We broke the Midwest. All
Finally.
right. There we go. East
Congratulations,
Coast.
Hogan.
Congratulations.
So I hope you enjoy that software and. Hey, design some boxes. Send us, what you're doing. Send us some pictures, and we'll probably put them up on the show. But we appreciate all you guys for registering. All things being equal, we're only 11 minutes or so past the hour.
Yeah,
but
that's short when I'm on the show. We're good.
Yeah, well, you and me both. So I'd curb myself many times because we could rant and go on forever because this stuff really is fun. So
No, when you're in the lab, it'll be a long show. It always is.
yeah,
So.
and don't forget, I kind of gave you that teaser. Sometime next year we're going to put that thing on the dyno and actually see what it really does, and we'll show you how we test amplifiers and real test with real banks of resistors, not just a real quick little tiny load.
Burst.
Yeah, with a burst. So, guys, thanks for watching. Tune in 2 weeks. We'll have some more fun. I think 2 weeks. I think we're going to be throwing some amplifiers in some fish tanks with water in them.
I've heard something about that.
So that'll be fun. Talking about one of our new lines of amplifiers. So tune in for that. And of course, always we're going to be giving away prizes. And you never know, maybe we'll feature one of your installs. So don't forget, Andy will not be on tonight. Andy's under the weather. Andy, I hope you get better soon. We love what you do on the show, and it's a lot of fun. And don't forget, if you guys are not already a member of the Kicker Club, you definitely got to get on that. So thanks, guys. Have a great Thanksgiving with the family. Eat too much like we all do, and we'll see you right back here in 2 weeks. So thanks for tuning in tonight. Appreciate it. And thanks, Joe, for being on the show.
Thanks for having me, sir.
See you guys.
Good night.